Hi friends, welcome to all. Today in this video we are going to see the lab activity troubleshooting inter VLAN routing. Here we can see the topology. Also we can see addressing table and the switch port assignment specifications. We will go through the objectives in part 1, build the network and load device configurations. In part 2, troubleshoot the inter VLAN routing configuration. In part 3, verify VLAN configuration, port assignment and trunking. And in part 4, test layer 3 connectivity. Also, we will go through the background. The network has been designed and configured to support 3 VLANs. Inter-VLAN routing is provided by an external router using an 802.1q trunk, also known as router on a stick. Routing to a remote web server, which is simulated by loopback 0, is also provided by R1. However, it is not working as designed, and user complaints have not given much insight into the source of the problems. So in this lab, we must first define what is not working as expected and then analyze the existing configurations to determine and correct the source of the problems. This lab is complete when you can demonstrate IP connectivity between each of the user VLANs and the external web server network, and between the switch management VLAN and the web server network. So this is what we are going to do in this lab activity. Here we can see the required resources, so one router 1941, two switches, two PCs, so then the required cables. Coming to part 1, build the network and load device configurations. In part 1, we will set up the network topology and configure basic settings on the PC host, switches and router. So coming to step 1, cable the network as shown in the topology. So we will build and cable the network as shown here in this topology. Here we required one router 1941, also two switches 2960 switches and two PCs. We will connect these devices. Connections, copper straight through. Here we are going to use G0/0 to fast Ethernet 0/5. Then from the switch, fast Ethernet 0/6 to this PC0. This is, we have to rename it as a PCA. We will do that. Then from this switch, fast Ethernet 0/18 to this PC. Also we have to connect these two switches using copper crossover. Fast Ethernet 0/1 to fast Ethernet 0/1. We will rename this display name here. This is R1, this is S1. Here we have S2. This is PC-A, and here we have PC-B. Also we will label the interface details. This is a G0/1, and here we have fast Ethernet 0/5. This is a F0/1. Here also F0/1. Here we have F0/6, and this interface is fast Ethernet 0/18. Also we will highlight this VLAN trunk. It note 2.1q VLAN trunk. Coming to step 2, configure PC host. Refer to the addressing table for PC host address information. Coming to our addressing table, here we can see the IP address of PCA and PCB. We'll copy this address and we will give it to this PCA. Here we can see the subnet mask, also the default gateway. Coming to PCA, desktop IP configuration. Here is the IP address, subnet mask, then the default gateway is 10.1. Now we will get the IP address of PCB. Here we can see that. We'll copy this address. Also we can see the subnet mask and the default gateway. Coming to PCB, desktop IP configuration, subnet mask and the default gateway is 20.1. Coming to step 3, load router and switch configurations. Load the following configurations into the appropriate router or switch. All devices have the same passwords. The enabled password is class and the line password is Cisco. So we are going to give these configurations on router or switches. Here we can see the configuration of R1. Also we can see switch S1 configuration and switch S2 configuration. So first of all we will do on router R1. Coming to the router R1. No. Enable configure terminal. We will set the host name R1. Enable secret as class. No IP domain lookup. Also we will go to line console 0 and we will set the password as Cisco. Logging, also we will give a logging synchronous. We will go to line VTY 0 to 15. Password as Cisco. Login. Also we will go to the interface loopback 0. And we will set the IP address 209.165.200.225 and the subnet mask 255.255.255.224. Now we will go to the interface gigabit Ethernet 0/1 and here we are going to give no IP address. Also we will go to the interface gigabit Ethernet 0/1.1 encapsulation .1q11. Also we will set the IP address 192.168.1.1 and the subnet mask 255.255.255.0. Coming to the next sub interface gigabit Ethernet 0/1.10 encapsulation .1q10 IP address 192.168.11.1 and the subnet mask 255.255.255.0. Now we will go to the interface gigabit Ethernet 0/1.20 encapsulation .1q20. Also the IP address 192.168.20.1 and the subnet mask 255.255.255.0. Now we will do it on S1. Enable configure terminal hostname as S1. Enable secret class. No IP domain lookup. Line console 0. Password as Cisco. Login. logging synchronous. Also we will go to line VTY 0 to 15, password as a Cisco, login, and we will create VLAN 10 and to name as R and D, and we will go to the interface fast Ethernet 0/1, switch port mode as access. We'll go to the interface fast Ethernet 0/5, switch port mode as a trunk. Now we'll go to interface VLAN 1 and we will set the IP address 192.168.1.11 and the subnet mask 255.255.255.0. Now we will set the IP default gateway 192.168.1.1. Now we will do it on IS2. Enable configure terminal, hostname as S2, enable secret class, no IP domain lookup, line console 0, password as Cisco, login, also logging synchronous, and we will go to line VTY 0 to 15, the password as a Cisco, login. Also we'll create VLAN 20, the name as engineering. Now we'll go to the interface fast Ethernet 0/1, switch port mode as a trunk, interface fast Ethernet 0/18, switch port access VLAN 10, switch port mode as access. Now we'll go to the interface VLAN 1 and the IP address 192.168.1.12 and the subnet mask 255.255.255.0. Also we will set the IP default gateway 192.168.1.1. Right, so here we configure all the devices. So this R1, S1 and S2 as per the configurations given in this lab activity. Coming to step 4, save the running configuration to the startup configuration. Right, so we will do on all the devices. Coming to R1, password is Cisco, enable, password is class, copy running config, startup config. Coming to S1, CLI, copy running config, startup config, and coming to S2, copy running config, startup config. Coming to part 2, troubleshoot the inter-VLAN routing configuration. In part 2, we will verify the inter-VLAN routing configuration. On R1, enter the show IP route command to view the routing table. So which networks are listed? We will verify that. Coming to the router R1, CLI, password is Cisco, enable, password is class. Here we are going to give a show IP route, and here we can see only one connected network is directly connected to loopback 0. Next is, are there any networks missing in the routing table? If so, which networks? Obviously, here we have seen only one connected networks, that is loopback 0. Coming to our addressing table, here we can see the interfaces for this device R1. Here given G0/1.1, 1.10, 1.20 and a loopback. So here we have seen only this loopback 0, and all other sub interfaces are not listed in this connected networks, I mean in this IP route. What is one possible reason that a route would be missing from the routing table? Coming to our topology, here itself we can see this interface G0/1, which is connecting to this S1. The link is down, so that's why it is not listed in the routing table. Coming to B, on R1 issue the show IP interface brief command. Based on the output, are there any interface issues on the router? If so, what commands would resolve the issues? So we will see that. Coming to R1, here we are going to give that command. Show IP interface brief, and we will verify that. Here we can see those interfaces. Gigabit Ethernet 0/1. Here we can see IP address unassigned, and it's administratively down. Also we can see protocol is down. So all the sub interface, here we can see that 1.1 IP address there, Gigabit Ethernet. Here we can see the IP address, but we can see the status is administratively down, so we have to bring this interface up. So here we are going to give a no-shut command on this interface Gigabit Ethernet 0/1 on the router R1. Configure terminal interface Gigabit Ethernet 0/1, and we are going to give no-shut command. So once we give this no-shut command, here we can see all the sub interfaces also changed its state to up. Here we can see the messages. Once more we will give the command show IP interface brief, and here now we can see the details. Here we can see Gigabit Ethernet, the status is up, but here we can see protocol is down. Right. Now here we can see the link between this R1 and S1 is up. So here what I have done is just reconnected this link on R1 to this interface Gigabit Ethernet 0/1. So it become up. Now again we will verify the details using show IP interface brief, and here we can see the details. Now we can see the status is up and protocol is also up. Coming to C, on R1 reissue the show IP route command. Verify that all networks are available in the routing table. If not, continue to troubleshoot until all networks are present. So we will give that show command again on this router R1. Show IP route, we will give connected, and here we can see the details. Now we can see all the networks, connected networks, total 4 connected networks. Same thing can be observed in our addressing table. Here we can see those 4 networks. Coming to part 3, verify VLAN configuration, port assignment and trunking. In part 3, we will verify that the correct VLANs exist on both S1 and S2 and that trunking is configured correctly. Step 1, verify VLAN configurations and port assignments. In that, coming to A, on S1, enter the show VLAN brief command to view the VLAN database. Which VLANs are listed? Ignore VLANs 1002 to 1005. Right, so we will give this show VLAN brief command on S1. Coming to our switch S1, CLI enable password is class, show VLAN brief, and here we can see the VLAN details. Here we can see the default VLAN. Also we can see the VLAN number 10 and name R and D. So here we got only one VLAN. Are there any VLANs numbers or names missing in the output? If so, list them. Obviously, because we have seen we have to create two VLAN, VLAN 20 and VLAN 10, but here we can see only one VLAN, that is VLAN 10. So we have to create this VLAN 20 with the name engineering also. Next is, are the access ports assigned to the correct VLANs? If not, list the missing or incorrect assignments. Coming to our topology, here we can see these two ports, that is fast Ethernet 0/5 and fast Ethernet 0/1 should be trunking. And coming to this fast Ethernet 0/6, here we can see which is connecting to this entity device should be an access port. Also we can see in our switch port assignment specifications, here we can see on S1 fast Ethernet 0/6 we must assign to VLAN 10. Coming to our previous show command on S1, here we will check that fast Ethernet 0/6, but it is not assigned to VLAN 10. Here we can see that there is no port assigned to this VLAN. And here we can see fast Ethernet 0/6, which is in the default to VLAN 1. So it's incorrect. Next is, if required, what commands would resolve the VLAN issues? Yes, we are going to give that commands on this switch S1. Coming to the switch S1, password is Cisco, enable password is class. Configure terminal, we have to go to that interface fast Ethernet 0/6, switch port mode as access, switch port access VLAN 10. Also we will create the missing VLAN on this switch S1. Here we can see that VLAN 20 engineering. So we will create that VLAN on S1. VLAN 20, name as engineering. Coming to B on S1, reissue the show VLAN brief command to verify configuration. Right, we will do that. Show VLAN brief, and here we can see the details now. Now we can see the VLAN 20 engineering. Also we can see the port fast Ethernet 0/6 is assigned to the VLAN 10. Now it's correct. Coming to C, on S2 enters the show VLAN brief command to view the VLAN database. So which VLANs are listed? Ignore VLANs 1002 to 1005. So we will give this command on S2 now. Cisco, enable password is class, show VLAN brief, and here we can see the details. Here we can see the VLANs, default to VLAN 1. Also we can see VLAN 10 and VLAN 20. VLAN 10 is, so here we can see the name is default VLAN name, and this is engineering, right? So we got two VLAN, but here we can see the VLAN name is the default to VLAN name. Next is, are there any VLANs numbers or names missing in the output? If so, list them. We have seen that actually VLANs are not missing, but here we can see this VLAN name is missing. Here we can see the default VLAN name, so we have to change this VLAN name as per our lab activity. Next is, are the access ports assigned to the correct VLANs? If not, list the missing or incorrect assignments. Coming to our topology, here we can see the interface fast Ethernet 0/1 should be trunking, and here we can see the interface fast Ethernet 0/18 which is connecting to this entity device. So this port should be an access port. Also here we can see this port should be assigned to VLAN 20, that is engineering. So we will verify that. Coming back to S2, and here we can see the port fast Ethernet 0/18, and we can see which is assigned to VLAN 10. Actually, according to our lab activity, this fast Ethernet 0/18 should be assigned to this VLAN 20. So it's incorrect. Next is, if required, what commands would resolve the VLAN issues? So we will implement that on this AS2. First of all, we will rename this VLAN 10. Configure terminal. We will go to VLAN 10 and we will name as R and D. And now we will assign fast Ethernet 0/18 to VLAN 20. So we have to go to the interface, fast Ethernet 0/18, switch port mode as access, switch port access VLAN 20. On S2, reissue the show VLAN brief command to verify any configuration changes. So we will reissue the show command here. Show VLAN brief, and now here we can see the changes. Now VLAN 10 name is R and D. Also we can see the port fast Ethernet 0/18 is assigned to the correct VLAN. Now we will come to step 2, verify trunking interfaces. Coming to A, on S1 enter the show interface trunk command to view the trunking interfaces. Which ports are in trunking mode? So we have to see that. Coming to S1, and we will give that specified show command. Enable password is class show interfaces trunk, and here we can see the details. Port fast Ethernet 0/5. Mode is on and status is trunking and native VLAN 1. Yes, so in this output we can see only one port is trunking. Are there any ports missing in the output? If so, list them. So coming to our table, here we can see on S1 these two ports fast Ethernet 0/1 and 0/5 should be trunking. So coming to our topology, we can see that very clearly. Fast Ethernet 0/5 it's already trunking, but this interface F0/1 is not trunking. If required, what commands would resolve the port trunking issues? So we will implement that on S1. We have to give this fast Ethernet 0/1 as trunking. Coming to the configuration, so we have to go to that interface, that is fast Ethernet 0/1, and here we have to give a switch port mode as a trunk. On S1, reissue the show interface trunk command to verify any configuration changes. We will check that. Show interfaces trunk, and now we can see here the output. Ports are fast Ethernet 0/1 and 0/5, both are trunking. Coming to C, on S2, enter the show interface trunk command to view the trunking interfaces. Which ports are in trunking mode? Coming to a topology, here we can see on S2 the interface fast Ethernet 0/1 should be trunking. Right. So are there any ports missing in the output? If so, list them. So we have to check that. Coming to S2, here we are going to give the command show interfaces trunk, and here we can see the result. Yes, this interface fast Ethernet 0/1 is trunking, native VLAN 1, it's correct. So if required, what commands would resolve the port trunking issues? There is no issue. Now we are coming to part 4, test layer 3 connectivity. Coming to A, now that you have corrected multiple configuration issues, let us test connectivity. Right. So from PCA, is it possible to ping the default gateway for VLAN 10? We will try that. First of all, we will get the IP address of VLAN 10 on this R1. Here we can see that IP address 10.1. We will copy this address and coming to PCA, desktop, command prompt, and we will ping to the default gateway. We are waiting for the replay. Request timed out. No, we are not getting the replay. Next is from PCA, is it possible to ping to PCB? So we will try from this PCA to PCB. First of all, we will get the IP address of PCB. Here we can see that. Coming back to PCA, command prompt and ping to PCB. And we are waiting for the replay. Request timed out. No, we are not getting the replay. Next is from PCA, is it possible to ping to loopback 0? We will get the IP address of loopback 0. Here we can see that. We will copy this address and coming to PCA, command prompt, ping to loopback 0. We are waiting for the replay. Request timed out. No, we are not getting the replay. If the answer is no to any of these questions, troubleshoot the configurations and correct the error. So everywhere we got no, so we will troubleshoot now. We will refer our addressing table. Here is that. And PCA IP configuration, everything is correct. We have to cross check on R1, CLI, Cisco, enable password is class, and here we are going to give a show running config and we are going to verify each interfaces. Here we can see the interface gigabit Ethernet 0/1.1. Here is that. IP address 192.168.1.1, 255.255.255.0, and here we can see the encapsulation is 11. Here we can see the encapsulation should be 1, so we have to change that. Then here we can see interface, the sub interface gigabit Ethernet 0/1.10. encapsulation .1Q10, it's correct, and here we can see the IP address 192.168.11.1. so it should be 10.1. so here the IP address is assigned incorrectly. Submit to mask is correct, and coming to the next sub interface G0/1.20, encapsulation is correct, IP address it's correct, submit to mask also correct. We will reconfigure these two major changes here. Configure terminal, we will go to the interface gigabit Ethernet 0/1.1, and here we are going to give encapsulation .1Q1, and now we will verify that. Show running config, and here we can see that interface G0/1.1, encapsulation .1Q1 native, and also we can see the IP address and submit to mask. Now we will change the IP address of the sub interface G0/1.10 from this 11.1 to 10.1. Configure terminal, we have to go to that sub interface G0/1.10, IP address 192.168.10.1, and the subnet to mask 255.255.255.0. now we will verify that. Show running config, and here we can see that it's correct. Also, we will verify the IP address of the interface loopback 0. Here we can see that on the addressing table 209.165.200.225, and here we can see the submit to mask, everything correct. Now we will try to ping from this PCA to the other devices. Coming to PCA command prompt, first of all we will ping to the default gateway. Here is that. Here we can see we are getting the replay. Now we will ping to PC2. Here is the IP address. We are getting the replay. Also we will ping to a loopback. We are getting the replay. Next is from PCA, is it possible to ping to S1? Also from PCA, is it possible to ping to S2? We will try that. First of all, we will ping to S1. We will get the IP address of S1. Here is that. Coming to PCA command prompt. Ping to the switch S1. Request timed out. No, we are unable to ping. Now we will try to ping to S2. Here is the IP address. Coming to PCA command prompt. Ping to S2. We are waiting for the replay. Request timed out. No, we are not getting the replay. Next is list some of the issues that could still be preventing successful pings to the switches. Maybe these switches configured with the incorrect IP address, or maybe the interface where we configured the IP address is down. So we have to check that. Coming to B, one way to help resolve where the error is occurring is to do a traceroute from PCA to S1. Here we can see that command and its output. This output shows that the request from PCA is reaching the default gateway on R1 G0/1.10, but the packet stops at the router. We can also verify that using this traceroute command on this PCA. Traceroute, and here is the IP address of S1. Oops, we have to give the space here, and now we will try. So we can see it reaches to the router R1. Then request timed out. Request timed out. No, we are not reaching to this switch S1. Coming to C, you have already verified the routing table entries for R1. Now execute the show running configuration command to verify VLAN configuration. List any configuration errors. Right, we will do that. First of all, we will come to S1. Cisco enable password is class. Show running config, and we will verify that to VLAN. Here we can see that interface VLAN 1. Here we can see the IP address 1.11 and the subnet to mask, and here we can see it's shut down. We can see the status show IP interface brief, and here we can see that it's administratively down. Also we will verify on S2. Password is Cisco enable show running config, and here we can see VLAN 1 IP address subnet to mask, everything is correct, but we can see this interface is down. Show IP interface brief, it's administratively down, so we have to give a no-shut command on this interface VLAN 1 on both switches. First of all, we will do it on S1. Configure terminal, we have to go to that interface VLAN 1 and we have to give an no-shut command. Now we can see VLAN 1 changed the state to up. We can verify that. Show IP interface brief, and here we can see the status and the protocol both are up. Now we will come to S2. Configure terminal interface VLAN 1 no shut. VLAN 1 changed state to up. Show IP interface brief, and here we can see that status and protocol both are up. What commands would resolve any issues found? So we given no shut command on both switches for the interface of VLAN 1. Coming to D, verify that the pings from PCA now reach both S1 and S2. From PCA, is it possible to ping S1? From PCA, is it possible to ping S2? We will try that. Coming to PCA command prompt, and we will give the IP ping to S1. Here is that. We are waiting for the replay. Request timed out. Request timed out. Yes, we are getting the replay. Once more we will give that. Here we can see we are getting the replay. Now we will try to S2. Here is that. And sometime we may get one or two requests timed out. Request timed out. Yes, we able to ping to S2 also. Here we can see that. And coming to a reflection question, what are the advantages of viewing the routing table for troubleshooting purposes? Obviously, this routing table is having a huge role in troubleshooting. We can see all the connected networks as well as the remote networks, whatever we configured. We can find those networks. Also, we can check the IP addresses. Also, we can check the missing networks. Well, so in this lab activity, we configured our packet tracer as per the instructions given first. Then in that there was some errors, and we troubleshooted all the problems. That was the lab activity, troubleshooting inter VLAN routing. Friends, if you have any doubt in this lab activity, please comment below. Also, if you like my video, give a thumb and share to your friends. Also, if you like to get my future uploading video info into your Gmail, you can subscribe this channel. Thank you.